We're going to combine two chapters in this section, Control Systems and Computers, which is Chapter 9, and Chapter 10, which is Energy Systems Maintenance. They're both actually pretty big chapters, but it's worthwhile to discuss them together since we're using the former to handle the latter. The idea of using the control systems is that it's going to help us to reduce the cost. If we can keep track of how our buildings are operating and the energy that they're using, we'll be able to reduce those costs. We'll be able to maximize profits. And that might be enough to keep the doors open in the business. So we have to do this, and there's a lot of tools that we're going to be able to use. Some of them are simple, others are maybe not so simple, and actually quite elaborate and complicated. As an energy manager, you'll be looking at that equipment, that software, and learning how to interface it with your daily work. The types of controls are actually pretty simple to break down. The simplest things are the manual systems, the light switch, the thermostat. So, but those count on human interaction. If I forget to turn the light off, it stays on. How often have you walked down to the basement only to find out that you left a light on? For how long? When was I down here last? This light has been on for a week. So that's one of the issues with the manual system. We can then go into basic automation controls. Timers and dimmers most specifically come to mind. And I think worth listing in with this might be motion sensing. It's simple to put a timer, for example, on that basement light. When I'm down in the basement, how often am I down there? Only for a few moments. So to put that on a timer, 5 minutes, that might be longer than I'm actually down there. Maybe I only go down there for 30 seconds, reset a circuit breaker, set something down, take something up. But if I'm down there longer than 30 seconds, it would be inconvenient to have to go back and reset that timer 4 times because I was going to be down there for 2 minutes rather than just the 30 seconds. So perhaps it would be simpler to just have it on for 5 minutes every time. That should be enough. Another thing to talk about are dimmers. Dimmers are a way of reducing energy, but unfortunately some dimmers only reduce the amount of light, but they don't reduce the amount of energy. They use what's known as a rheostat. So they take the entire amount of voltage and they divide it so that only a small amount of the voltage is going to the light bulb. The remainder of that voltage and current in the form of power then is going to be eaten up by the potentiometer itself, not doing any work for us whatsoever except actually providing a heat load in the light switch. So the next part that is discussed in the textbook are called programmable controllers. We can add this up. This can also be added into programmable logic controllers. This is a type of a system that's not quite a full-blown computer, although they are becoming much more powerful. And so it's going to analyze data from sensors. Sensors could include light sensors, temperature sensors, humidity sensors, wind speed sensors, wind direction sensors, the amount of sun that's falling on a building. So there are many things that we can sense and then be able to analyze that data and determine what needs to be turned on and turned off. For example, if the humidity is too high in a building, people will feel uncomfortable. So it's not enough just to remove the warm air. Perhaps we need to remove some of the humidity. And we'll do that with air conditioning systems. So these controllers have to be programmed. They have to be installed correctly, and Many places have their HVAC personnel attend building automation uh, uh, courses. We offer one here at Madison College, and we do just that. It takes the HVAC technician beyond actually just installing the furnace, installing the boiler, installing the air conditioning, doing the maintenance on it. We have to be able to control it properly. We have to be able to identify when something isn't operating correctly. A good example that the authors mention is what a timer will do for us. Timers are based on a 24-hour clock cycle most of the time. So if, for example, the timer loses power because of a storm, because of an equipment malfunction, and when time is restored, the timer will quite often just continue ticking away from wherever it left off, or maybe it will start over from 12 midnight. At any rate, if the timer doesn't know what day and time it is, it would be possible, and in fact likely, for it to be operating on a Tuesday when in fact it's Saturday. And it might think that it's 8 p.m. when in reality it's 12 noon. So these are some of the things that can cause us difficulty in doing our maintenance is by not knowing which timers need to be reset when there's when there's a power outage, but where they are and getting someone around to do that work. So those are the simple basic controls. Most of our programmable controllers and computerized systems have the ability to note that there was downtime and that they can go out and find the exact time and date and update all the appropriate files so they know to run the correct Tuesday afternoon at 2 p.m. format for what we want the temperature and the lighting and the humidity to be. So these are pretty important. Most of the HVAC companies are using what's known as building automation systems software. So they're tying together not only all the components that an HVAC system would need, but maybe we're tying together all the HVAC systems and the lighting systems and so forth. And we have this all under one control so that the energy manager or the facilities manager in many cases can handle all of those tasks. Again, I got ahead of myself a little bit there. We're going to use software to allow us to control all aspects of the system of the building and bring it to the desired conditions, which we refer to as comfort. We want the people in the room, in the building, to be comfortable. Well, if there's nobody in the building, there's no sense in having a high amount of ventilation or or conditioning. By room conditioning and air conditioning, we mean we might be heating it, cooling it, drying it out, adding moisture, um, raising or lowering building pressures. There's many ways that we can do this, and their building automation classes it's a great way to learn how to do this. These are some of the things that the software will allow us to look at: the electrical, lighting, heating and ventilation, plumbing, fire protection, security, that's right, access control systems. Access control systems, again, they fall under this BAS software quite often. And we may have surveillance systems, the voice over data video systems. Even elevators might need to be tied into this entire system so that we can understand our energy use. I'm going to get back to the software here in a moment, but because I also want to talk about some software that's available for for analyzing how much energy my building is using. Now we can see from this screen here that I've updated the PowerPoint file because some of the things that are referenced in the book are no longer available. I'm going to take a moment now to go over to one of the first places that's listed on our list here, the DOE2. So I'm going to go over to the web right now, and on the web we're going to see the DOE2.com website. We can read this over. I put a link on this in your Blackboard file so that you can click right to this file. And from here, I launched off and I looked at many other things. And I'm going to show you these. Many of these. You can see I've got a lot of tabs open up here, and I will click on each of them and mention a little bit about things. So the DOE2 was brought about quite a few years ago, and it was originally brought out before the advent of Windows. So we were using computers to do things without the ability to have the graphical user interface. And so we're going to read here that the first thing that they're trying to get us to use is a program called eQuest. Well, eQuest is the fully it's supposed to be the easiest one for us to use because it uses the graphical interface, and there's an overview that I've already clicked to show us just what it is. So eQuest, Quick Energy Simulation Tool, and this is a 19-page document that you can download and read, and it gives us a little bit of history on how it came about. After 2 decades of continuous development and enhancement, the DOE2 is the most widely recognized and trusted building automation simulation program today. All right, so so that's the DOE2, which is still available, but it discusses the latest version of the software, which I have not downloaded onto my Mac. I will put that on a Windows-based machine, and um, or I have rather, but I don't have it displayed here on my presentation. Feel free to download this and start looking around. It's very, very powerful. Um, so and one of the nice things about it, as we read down here, it has the ability to bring in data. It has the ability to bring in files. I'm making my way down here to bringing in files that were created with other design software such as AutoCAD. This is pulling in a file that has a .dwg file extension, and that's used with AutoCAD. So the DOE version, right? So again, back on this page, it says eQuest, right? This is the latest and greatest, coolest thing. And we can see the dates on these, 2005, 2009. Seems a bit dated. They did update the IRS files here. Okay, so this software is actually used and relied upon for many tax uh, um, requirements. So that's an important aspect and a reason why we may want to use this. So when they list here, the next one that's down is called DOE2. So again, this is freeware, but if you look a little bit closer, we'll realize that this particular version, DOE2, it's pretty much sort of a DOS-based thing. It runs in a DOS window, right? And so it explains the history of it. Here now we have 30 years of development support, and it talks about the different ones. But it says, why don't, instead of using DOE2, why don't you use eQuest? Because what it does is it grabs the DOE 2.2 version and adds to it wizards and graphics to make it easier to use. You can still use this if you're interested and if you like running the DOS stuff, the DOS-based things. And notice not just a month ago, in March of 2014, that we have a new version, 2.3. Okay, and so this would be something that maybe some of you would want to install. Notice it's 43 megabytes. Okay, I have not installed or goofed around with this one yet. I did look at it at one of the older ones the last time I taught this class, but I have not done it this time, mostly because I think the eQuest would be the right way to go. So I went one more step further and I clicked on what do we have to do to install and run this new DOE 2.3, and you'll notice it's a DOS-based thing. We're going to put things literally right into the C drive, right? It's going to create its own directory, and away we'll go. So um, again, also, I'll go back to this main page here. So this main page where we were listening at the DOE2, we had eQuest, we had DOE2, a couple more things is this weather data. So the weather data is right here. And the weather data is important information that is going to upload the characteristics of where we live. And you can see that there are several different styles of data available. If we need Canadian data, we click on one of these first two. We have California specific, and now we're going to do the TMY, TMY2, right? Now, so this is typical meteorological year, and this is getting data from United States weather stations, and also NREL weather stations would be for TMY2, and then finally TMY3, which is recently put out here, is going to tie together the DOE, the NREL, and the NDC sites. So what does it look like when you grab those? Well, I'm just going to grab on the TMY. We'll see what that says. So when I click on TMY, if you've had some of my other classes, I think Introduction to, PV site assessment, we actually use this. Oh, nice. My internet is down. Let's try that one more time. Okay, so notice on this, the DOE2, here's our download where we're going to get our typical meteorological information. Notice they've got the data shown up in bins here: Adak, Alaska, Akron, Ohio, Albany, Albuquerque, Allentown, PA. Let's get down to something maybe we would want, like maybe Madison, Wisconsin. Sure enough, there's Madison, Wisconsin. And when I click on this, it's going to give me the data in the form of in the form of a bin, which is raw data. And it'll download to my computer, which I then have to use some other piece of software to analyze that data. All right, so this is just the start of it. So again, we got that by using, by clicking on the weather data and the TMY. That's how we got there. Back to the site. Next, they talk about Power DOE. Well, Power DOE is not updated, is not available, and it's been discontinued in favor of eQuest. Oh, okay. So we don't want to use that anymore. The last thing that I want to mention on this site here is this life cycle costing analysis, which is shown here, the LCC, or the BLCC, which is the Building Life Cycle Costing software. And it mentions how the National Institute of Standards and Technology and ANSI have put this data available so that you can analyze this information all in one site. So we can download the program, but notice it says, although the procedures used in the BLCC have long been published, and it shows where we can do that. Some users express concern that it does not display immediate details of its calculations. And so for this reason, they developed a spreadsheet version of these procedures. That spreadsheet version is available by clicking right there on the Office XP format. So I'm going to show you now what I downloaded. I think it's telling that it says that the last time this was updated was June of 2008, and it was posted in January of 2009. So that's roughly 7 years ago. So I'm wondering about its accuracy. So I'll go over to the Excel spreadsheet now that I have opened, and notice it's got lots and lots of tabs. And what this does for us is it allows us to put in the information based on a particular year, and it's going to do a lot of the calculations that we've done already in this class. Very interesting that most of these tabs, LCC 0 through 9, are basically the same thing. They're using different types of glass and glass glazing. So that's pretty interesting here, because we'll be able to then determine by having different types of glazing on the windows, we'll be able to see just how much energy we're going to be saving. So that's what all these different tabs are. So it's kind of interesting. When we run over to the results summary, it's going to give us, again, an example. This is an example and analysis. So if I replace my windows with this type of glass or another type of glass or so forth, that will then be able to be reflected on the amount of energy that I save, the amount of maintenance. There's a category for this. and we'll end up seeing just how much money we're going to save. Um, and notice there's a savings to investment ratio data that's listed here that doesn't count for these life cycle costs, but when we put the savings in, now it's showing me just what I'm saving. So we can determine, by changing my window glass out, just how much am I going to save and what'll let my investment return be. And we can see some of those numbers here. So um, I find that this has of limited value. If this tool is going to do for me is show me what I'm going to be saving by changing different types of glass, that's got limited value for me. Of course, if I have to be able to show what my, a nice screen here so that, we can get a chart that gives us a snapshot of the performance that we would get. Single present value, we've done enough of this in our classes. I think you remember that. I hope so anyhow. A uniform present value, again, this is a slightly different term of what we've used before. A uniform annually recurring cost, that's the annuity type thing that we had seen before. If we're going to make a certain amount of money every month for such and such a time. So, and if we were to change this rate, notice I don't want to change it here, right? When I clicked on this 3%, it says I want to change it on the general data, that's this tab, M10, right? So if I come over here to M10, here's M, here's 10, there's that blank. If the current data for 2014 was 6, I change that here, it will change over on the it'll change in various places on this spreadsheet. And that's the beauty of the darn things. So all these numbers would change, and I'd be able to calculate my savings. A lot of work went into this. I sent when we go to the main page on this, I think there might be one more tab, non-modified fuel, yeah. But if I go back to the beginning, if I go back to the main page under general data, I'm going to zoom this up a little bit so we can see what we've got. All right, so it's going to show, important note, this spreadsheet should be updated and replaced every April after the Department of Energy releases updated energy and price escalation factors. And it tells me that I could get in touch with Marlon Addison and ask him if those files have been updated and if they're available. Because going to the website shown here, this is the latest copy that's available. So my question would be, is it possible for me to get this information and plug this information into the tool and have it work just as well? We'll see what he says on his reply to my request. Or he may not say anything. I may not get any response. I'll be certain to let you know what I find out. So back on the web sheet, that was the life cycle costing. Now I want to point out a few more things here. So that was the life cycle costing. One of the spots it told me is that I could come back here and it would show me what was changed in these different. So that's part of the LCC. And one of the links it had for it was to tell me how to use this, right? And this is dated 1999. So this is sort of an issue here, that we've got some dated materials and whether we're going to be able to use this in a long-term fashion. So back on my spreadsheet, or not my spreadsheet, back here, I have updated some of the files that are available. So BLAST was one that was listed in the chapter, but when I tried to find BLAST, I struggled, but eventually found that it has been taken over by EnergyPlus.net. Okay, so EnergyPlus.net, right? I think I got things out of darn it. I'm going to get back to that one. EnergyPlus.net. wonder where that tab went. Next is another one called Access. Access has been purchased and is now, or the name change is now called Climatech, right? And Access, this is Access Climatech. You know what? I think I was okay with that. I think E-Cube is what was once Blast. I'm pretty sure E-Cube is what was once Blast. Yeah, because if I go back one site here, let's see what it says. E-Cube. I did a search for Blast, and this is what came up: is that E-Cube took that over. So, um, and this is experts in facility optimization. They are what's known as a commissioning authority and a commissioning agent. Well, what does that mean? So let's say you pay some local contractor to come in and build your building, and it subcontracts out the HVAC system, the security system, the fire system. All these different systems are supposed to work under one integrated approach. Well, do they work? Do they do what they were advertised to do? How am I supposed to know? I just want to run my business, right? And my business it may have nothing to do with having an energy efficient building. So eCube is a company that will actually come in and talk with the installers and look at your building and to find out if it does what it's supposed to do. So you can look at that sheet. Here we have another software tool that can be used. Again, it used to be called Access. Now they have a variety of things. We can do the enterprise management. We can look at the entire building. Notice they're giving us a nice graphic here. Lighting, security, HVAC, life safety, utilities. So we can tie all of that in, and notice we've got one nice graphical use. And you can bet that you would also be able to have this sent to your smartphone. Optimize. This is another tool very similar to the one we saw before, only in this case we're trying to find out, is my plant operating correctly? Um, uh, is the building envelope being handled correctly? How is the building being handled? And then lastly, we want to be able to monitor. Continuous monitoring support. So these are people who would be available to monitor your building and all aspects of it, and provide security, provide alarm response, and so forth. So this is an example of some of the places you may end up working. And let's go back to this. Another thing that was listed here was Train. It was actually called Trace. Trace was a program that was run by the Train Corporation. Well, so when I started looking at this is the software right here. Well, this is unique to Train equipment. So what if you don't have Train equipment in your building? Are you going to be able to use this? Probably not. So you're going to have the hardware installed in order to use this. And as I was thinking about that, I found another website called the Whole Building Design Guide. Right? And the Whole Building Design Guide, this is a great link right here. I'm going to put a copy of this in on the web sheet, because this is a great link right here. So back 10 years ago, or I'm sorry, 6 years ago, this engineer, he put together a overview of a variety of different pieces of software and tools that could be used for energy analysis. And so this is well thought out. And notice he talks about load calculation and HVA sizing tools such as Trace and DOE2 and Blast, and another program called Energy Plus. So in poking around trying to find information on these old ones, I found some new ones. So let me get back to that one. So this is Energy Plus, right? Energy Plus. It's has replaced Blast, and it's the innovation simulation tool that's going to allow me to do analyzing the capabilities of the building in hours, minutes, I can look at different zones. I can look at such a variety of things that include now even PV and fuel cells. Notice the version of this it's going to run on Windows, or it'll run on Linux, which means it'll probably run on a Mac. So when I went to their website, right, that took me, so when I took to that link and says, all right, so it tells me just what this energy simulation software will do. Okay, notice it's going to be grabbing weather data down here, right? And then finally, when I clicked on this website, it took me to this download spot. So here's the latest downloads. Now, the latest download is 8.5. Earlier releases might be more stable, but so here this one is, and so this could be installed, and I'm not putting it on this machine just now. You may want to do that. So I had mentioned BLAST before, and again, from this whole building design page, I put BLAST in and it explained what this was, and it also said that BLAST features are now incorporated in Energy Plus. So, but this is a great web page. So here's life cycle costing analysis, right? Where did we see that before? Remember we saw that spreadsheet? Well, what happens if we go here? Let's take a look at life cycle costing analysis. See, it's thinking, still thinking life cycle costing analysis. All right, so this is another option that's similar to that spreadsheet that we pulled up. And let's see if it's going to tell us. I didn't look at this before. This is the first time I've seen this. So the point I'm trying to make here is that the textbook is limited in what it can tell us. It's as soon as it's printed, it's out of date, right? As soon as that textbook is printed, it's out of date. So that being said, we're going to end up using the internet for most of our research and resources. All right, let's go back to this. So that ends the chapter on control systems and computers. Now I want to point out that there are some examples that are shown in the textbook of the layout of how these things are going to be wired together. The building automation class that I mentioned to you, we physically do that. We physically wire the things together in a variety of topographies. We use the most common modern style. We'll be using the Cat5 cabling that's used for the internet, and we'll have IP addresses for many things. So that may actually set aside, and who knows, maybe we'll have wireless phone use in the future. Things are changing rapidly, and it's all about bandwidth and data, so we have to be able to have that. That, however, it needs to be said that many of the buildings you may be working in still have some old systems that are working just fine, that use some of the older topologies that were pointed out there. So the star topology and where did it go? There did it go. So the star network and the common bus networks that are shown in the textbook on figures, I think 9-3 and 9-4. You're still going to see those, okay? You're still going to see those. So I want to talk about energy systems maintenance. More and more, we're going to have what's called a CMMS, okay? Computerized Maintenance Management System. I teach a class called Maintenance Management, and we deal extensively with a CMS software that works pretty well. And there are many different ones that are out there, and they can all be used, and it takes a certain amount of corporate buy-in. They have to be willing to utilize this tool, and it can do many things for us, but mostly it's tracking all of our equipment. B, it can track its performance. We can literally have it look at data collection points. We can have it look at pressures and temperatures and humidities and so forth. And those can be tracked. And if we can track it, we can then find out what the trends are. We can find out if we're losing money here or there. So this is an awesome tool that we need to see. I'm going to go back to the website for a moment because I want to show you this section right here. So this is, again, part of the whole building design guide. What is CMMS? Right? I'm going to make this a little bigger. Okay, CMS. It's a computerized maintenance management system. So, and so this is this was written not that long ago, not even a year ago, and it discusses what CMMS is, and describes it, talks about the environment. It does not endorse any particular brand at all. So the one that I used in my maintenance management class last year has been changed, and we're going to have, it's been updated so that it won't run on the older Windows machines. I'm going to be attending a webinar next week to find out exactly what I'll need to change so that we can teach that again next year. So we haven't had that class. We'll be offering it in the fall. So notice some of the lessons learned, do's and don'ts. Don't try to develop a CMMS in-house. Okay, you'll spend a boatload of time on it. I like this one here. Don't make this your primary payroll and accounting system. Okay, this is a work management system that requires data relating to time and costs, but it's not employees related. Yes, we'll put the employee stuff in there, and we can put some stuff in there, but it's not a good idea to plug all that in and rely on it, because when it goes down, everything's down. So, and that's one of the issues. If we need to make sure that we don't put all of our eggs in one basket. There's a discussion here. Failure of CMS implementations is a continuing problem voiced by industry experts. Avoiding the pitfalls of decision making should help. What does that mean? That means a company spends a boatload of money to buy into the CMMS, but it might be too cumbersome. It may be difficult to put the data in. It may be difficult to track the data. And if it's too difficult, people aren't going to do it. And if we're not going to do it, the data we could get from it will be skewed and it will not be helpful. So we need to make sure that we can find a data tool that works, that's easy to use, and that we can make sure that our employees are actually putting the data in. All right, again, let's just go through this. So maintenance program is one of the first victims of any cost-cutting efforts, right? The benefits of having a system, it's going to, believe it or not, it keeps equipment from failing. It will help keep energy costs down. For example, if all of a sudden I noticed that I have a large heating bill, or not heating bill, my electric bill has gone way up. And this might be correlated with maybe we had just reduced the number of people on maintenance. Well, if there's less people on maintenance, less maintenance will be done. So what happened? Maybe somebody didn't literally clean the filters for the HVAC system. So if I don't clean the filters, what happens? The motors have to work harder. They have to try and pull fresh air in through that dirty filter. And so they run harder, they run longer, I have more energy. And all this because the maintenance guy didn't have time to go and replace those filters. Now, it may not be a management issue. It might be that you got plenty of maintenance guys and they're just not doing it. So again, the CMS, if we tie everything together, we can keep track of these things and keep better control. Again, if we have data that's going to give us information about all of my systems, and also keep track of what the weather conditions are, what's the climate like, how is the thing operating, and what is it going to be, and by it I mean the system, what is it being requested to do? Well, if we have increasingly hotter and hotter summers, we can expect that our system is going to require more maintenance. We can expect that there might be more breakdowns. Maybe we'll have to replace things sooner. So those are things that we'll keep track of. And again, if we don't have the data, we're not going to be able to do this information. So The continuous approaches will, of course, be to gather the data and look at it. And from this data, we can determine which maintenance tasks, which EMOs we're going to go for, which ones we want to try right away, which ones we might have to put off until the next time that system needs to be replaced. So we have to look at all the information that's available to us. So the analysis after we have the data. Did we do this right? Well, maybe it wasn't such a good idea to install that particular HVAC system or that particular chiller. Or was it a good idea that I put in a air source heat pump? Maybe I should have spent the extra money and put in a ground source heat pump. Did I look at all the data correctly? Did I cut myself short by spending too little money now, and it's going to cost me a lot of money over time? So let's not be afraid to owe up to our mistakes, because we're going to have to make those decisions again. So continuous improvement is always important, and it's going to help us figure out what we need to do next. So that covers the 2 chapters on control systems and energy systems maintenance, both very important, and we need to make sure that we have good programs in place and that we can follow them. It takes management commitment to do this, and unfortunately sometimes when things get tight, those positions get cut, and that can be a bad thing, a very bad thing. So let's go back here.